Good morning, students. Welcome to Laksha Academy YouTube channel. We completed the two parts of semiconductor devices. I summarized the few concepts. A p-type semiconductor is electrically neutral. A n-type semiconductor is electrically neutral. The majority charge carriers in p-type semiconductor are holes and minority charge carriers are electrons. In n-type semiconductor, the majority charge carriers are electrons and minority charge carriers are holes. When a p-type semiconductor and n-type semiconductor are suitably joined, p-n junction diode can be formed. At the junction, a depletion region can be formed. So in this region there is no mobility of charge carriers. Generally, in the case of p-n junction diode, the width of the depletion layer is in the order of 10 power minus 6 meter. A potential is developed across the depletion region, that is called as barrier potential. For silicon, the barrier potential is about 0.7 volt and for germanium it is about 0.3 volt. p-n junction diode has two electrodes. If p side is connected to positive terminal of the battery and n side is connected to negative terminal of the battery, then we can say that the p-n junction diode is in forward bias condition. In forward bias condition, the width of the depletion layer decreases and conduction increases, resistance decreases. So when a p-n junction diode is in forward bias condition, the current is from p side to n side, and in this case the current is mainly due to diffusion of electrons. For an ideal diode in forward bias condition, it offers zero resistance. Next one, the p side of a p-n junction diode is connected to negative terminal of the battery and n side is connected to positive terminal of the battery. Then we can say that p-n junction diode is in reverse bias condition. In reverse bias condition, the width of the depletion layer increases, conduction decreases, resistance increases. In reverse bias condition, the current is due to drift of charge carriers, and in reverse bias condition the current is from n side to p side. Okay, p-n junction diode can be used as rectifier. Rectifier is a device which convert AC to DC. A p-n junction diode can be used as half wave rectifier and full wave rectifier. And a special purpose diode which operates in breakdown region is called as p-n junction diode. p-n junction diode can be used as voltage regulator. Next, we move to the next topic. This is the part 3 of semiconductor devices. In the part 3, we will learn a transistor, types of transistors, and conduction in transistors and characteristics of transistors we are going to learn. This is the part 3. These are the types of transistors available in the market. So for the understand purpose I have given that. A transistor. What is meant by a transistor? Transfer of resistance. A transistor is a combination of two words, transfer and resistor. Transfer of resistance. Transfer of resistance takes place from input to output section. Transfer of resistance takes place from input to output section. Transistor is nothing but transfer of resistance. How a transistor can be formed? How a transistor can be formed? To an extrinsic semiconductor, extrinsic semiconductors are two types that you know, that p-type semiconductor or n-type semiconductor. To an extrinsic semiconductor, the opposite extrinsic semiconductors are sandwiched on either side, then a transistor can be formed. So a transistor formed by sandwiching one type of extrinsic semiconductor between other type of extrinsic semiconductors. By sandwiching one type of extrinsic semiconductor between other type of extrinsic semiconductors. Okay, so a transistor can be formed by sandwiching of an extrinsic semiconductor by other type of extrinsic semiconductors on either side to it. There are two types of transistors. First, to a p-type extrinsic semiconductor, p-type semiconductor, if n-type semiconductor sandwiched on either side, Npn transistor can be formed. So Npn transistor contains a p-type semiconductor sandwiched between two n-type semiconductors. So Npn transistor contains p-type semiconductor sandwiched between two n-type semiconductors. Like that, PNP transistor contains n-type semiconductor sandwiched between two p-type semiconductors. There are two types of transistors. First one is NPN transistor and second one is PNP transistor. Yeah, consider a p-type semiconductor. This is a p-type semiconductor, and the other type extrinsic semiconductors, n-type semiconductors, are sandwiched on either side of p-type semiconductor. Okay, and like that, this is n-type semiconductor. On either side, two p-type semiconductors are joined. This is PNP transistor. PNP transistor. So this is NPN transistor and this is PNP transistor, and I show the symbols of PNP and NPN transistors also. Okay, so to an extrinsic semiconductor, the other type of semiconductors sandwiched on the two sides of it, a transistor can be formed. There are two types of transistors, Npn transistor and PNP transistor. And this is emitter. A transistor has three electrodes, and one of the electrode named as emitter, and this part is heavily doped. Okay, and this is base, and this is collector. So in NPN transistor, the base is p-type semiconductor, the emitter is n-type semiconductor, the collector is n-type semiconductor. In the case of PNP transistor, the base is n-type semiconductor, the emitter is p-type semiconductor, the collector is p-type semiconductor. Okay, so a transistor has three electrodes, like a diode has two electrodes. A transistor has three electrodes. The electrodes can be named as emitter, base and collector. The three electrodes of a transistor named as emitter, base and collector. Yeah, this is the symbol of Npn transistor. Symbol of Npn transistor, and in the diagram the arrow represents the direction of conventional current. So in the case of Npn transistor, the convention current is from base to emitter. Okay, this is the symbol of Npn transistor. And this is the symbol of PNP transistor. In the diagram, the arrow represents the direction of conventional current. In the case of PNP transistor, the conventional current is from emitter to base. Okay, these two are the symbols of NPN transistor and PNP transistor. Okay, the base is lightly doped, emitter is heavily doped, and collector is moderately doped. And the function of emitter is to supply majority charge carriers. Okay, next. Actually, symbol of transistor. Yeah, next we move on to action of NPN transistor. In NPN transistor, the base is a p-type semiconductor and the emitter is n-type semiconductor. The collector is n-type semiconductor. Emitter is heavily doped. Base is lightly doped. And collector is moderately doped. So to an external circuit, a transistor can be connected in a way that the emitter base junction always connected in forward bias condition. The base collector junction is always joined in reverse bias condition. Okay. Yeah, look at this. Emitter base junction is joined in forward bias condition because this is n-type semiconductor. N-type semiconductor is connected to negative terminal of the battery and p-type semiconductor connected to positive terminal of the battery. So this is nothing but emitter base junction is forward bias. Emitter base junction is forward bias. Note down that a transistor is always the emitter base junction connected in forward bias condition only. And this is n-type semiconductor. N-type semiconductor is connected to positive terminal and p-type semiconductor is connected to negative terminal. So this is a case of reverse bias. So collector base junction is connected in reverse bias condition. So in external circuits, the collector base junction is always connected in reverse bias condition only. So when a transistor is connected to an external source and these electrons, negative charge carriers, are repelled by the negative terminal of the battery and they move to that P region. So the direction of conventional current is opposite to the flow of negative charge carriers. So this represents the conventional current I, current through emitter. And this is current through collector. In the case of Npn transistor, the arrow represents the direction of conventional current base to emitter. Base to emitter. And the potential difference across emitter and base is represented like this, and this is VEB. In some of the textbooks they mention that VBE also, voltage across emitter base. Voltage across emitter and base. And this is voltage across collector and base, VCB. In some of the books they mention that VBC also, both are same only. VCB, voltage across collector and base. Okay, this is the current flow directions IE, IB and IC. Okay, emitter current, base current and collector current. Yeah, in the case of NPN transistor, the arrow mark on the emitter is coming away from the base and represents the direction of conventional current, direction of flow of current, and it is opposite to the flow of electrons, which are the main charge carriers in N-type. The main charge carriers, majority charge carriers in N-type are electrons. Okay, so And when an NPN transistor is connected to the external source and the direction of current flow shown in the diagram. The emitter junction is forward biased with emitter base battery, that is VEB. The collector junction is reverse biased with collector base battery VCB and voltage across collector and base. And in forward bias, the emitter base circuit helps the movement of electrons, that is majority charge carriers in N-type semiconductor in the emitter, and holds majority charge carriers in the base towards the junction between the emitter and base. This reduces the depletion region at this junction. Students, once again note down that the emitter and base junction always connected in forward bias condition only. When it is forward bias condition, there is movement of electrons in the emitter and holes in the base towards the junction, and by this way the depletion layer decreases at this junction. On the other hand, the reverse bias of the collector base circuits forbids the movement of majority carriers towards the collector base junction, and the depletion layer increases because base collector junction is forward bias condition. And the electrons in the emitters are repelled by the negative terminal of the external source, and base is thin and lightly doped. So very small quantity of charge carriers are available, nearly 5%. So 5% holes combine with the electrons. The remaining electrons rush through the collector and are swept away by the positive terminal of collector base battery. Note down that emitter is heavily doped and base is lightly doped. So if it is lightly doped, only few of the electrons from emitters can be combined with holes, and the remaining electrons rush through the collector and they are attracted by the positive terminal of collector base battery. This is important. So for every electron hole recombination, at the base region, one electron is released into the emitter region by the negative terminal of the emitter base battery. So for every electron hole recombination, an electron is released to the emitter because of negative terminal of emitter base battery. So the deficiency of electrons caused due to their movement towards the collector is also compensated by the electrons released from the emitter base battery. So previous we discussed that electrons rush through the collector region, so maybe deficiency of electrons takes place, but because of the negative terminal of emitter base battery, and electrons are moved from base to emitter. The current is carried by the electrons both in the external as well as inside the transistor. The current is carried by the electrons both internal or inside to the transistor or outside to the transistor. So the total current IE equal to IB plus IC. So in the case of a transistor, IE equal to IB plus IC because emitter is heavily doped. Okay. So in the case of Npn transistor, more number of electrons rush through the conductor region and they are swept by the positive terminal of the collector base battery. So IE equal to IB plus IC. So in the case of transistor, note down that IE equal to IB plus IC, and in most of the numericals you use this relation IE equal to IB plus IC and emitter current equal to base current plus collector current. Yeah, next we move on to action of PNP transistor. And a PNP transistor, base is N-type semiconductor and emitter is P-type semiconductor and the collector is P-type semiconductor. So the base is lightly doped. So here N-type semiconductor is lightly doped, the emitter is heavily doped. So how a PNP transistor connected to an external source, what happens, we will discuss. Yeah, always whatever may be NPN transistor or PNP transistor, the emitter base junction is a forward bias condition and collector base junction is reverse bias condition. So here emitter and base and emitter is P-type semiconductor. So that's why we have to connect these two negative terminal. Look at this. Sorry, positive terminal. Yeah, emitter and base junction is forward bias condition. P-type semiconductor is connected to positive terminal of the battery and N-type semiconductor is connected to negative terminal of the battery. This represents that emitter base junction is forward biased. Emitter base junction is forward biased. And collector P-type semiconductor is connected to negative terminal of the battery and N-type semiconductor is connected to positive terminal of the battery. So this represents base collector junction is reverse biased. Base collector junction is in reverse bias condition. Students, note down that whatever may be the NPN transistor or PNP transistor, always the emitter base junction should be in forward bias condition and base collector junction should be in reverse bias condition. Yeah, this positive terminal of emitter base battery pushes the majority charge carriers in emitter region to the base, but base is lightly doped. Only 5% of the majority charge carriers in emitter region combine with majority charge carriers in base region, and the remaining about 95% pushed into the P region, and those are attracted by this negative terminal of the battery. Okay. A symbol of PNP transistor, and this is the symbol of PNP transistor, and here the conventional current is from emitter to base. Yeah, this is voltage across emitter and base VEB, and this is voltage across collector and base. And IE, IB, IC represents the emitter current, base current and collector current in the case of PNP transistor, and IE towards emitter and IB towards the negative terminal of VEB. In PNP transistor, the arrow mark on the emitter is going into the base and represents the direction of flow of current. It is same direction as that of movement of holes, which are majority charge carriers in p-type crystal. Okay. So the majority charge carriers in p-type semiconductor are holes and emitter is heavily doped. So because of that, there is a drift of these positive charge carriers into that collector region. The emitter junction is forward biased with the emitter base battery VEB. The collector junction is reverse biased with the collector base battery VCB. So in forward bias of emitter base circuit, it helps the movement of holes. Holes are majority charge carriers in emitter region in the emitter, and electrons, which are majority charge carriers in base towards the junction between the emitter and base. So this reduces the depletion layer. So width of the depletion layer decreases at emitter base junction. So on the other hand, the reverse bias of the collector base circuits forbids the movement of the majority carriers towards the collector base junction, and the depletion layer increases. So depletion layer increases, like that NPN transistor, the same procedure. Here the holes in the emitters are repelled by the positive terminal of emitter base battery. So the base is very thin, that means lightly doped. Therefore only the few fraction, that means about 5% of the holes from the emitter combine with the electrons in N region. The remaining holes are rushed through the collector and are swept away by the negative terminal of the collector base pattern. Okay, only 5% combine in the base region, and remaining 95% rush through the collector and they are attracted by the negative terminal of the collector base battery. So for every electron hole recombination that takes place at the base region, one electron is released into the emitter region by breaking the covalent bond, and it enters the positive terminal of the emitter base battery. The holes reaching the collector are compensated by the electrons released from the collector base battery. Already we discussed that. The current is carried by the electrons in the external circuit as well as that of inside the transistor also. So the current, the total current is given by IE equal to IB plus IC. IE represents current due to emitter, and IB current, base current, and IC collector current. Okay, so this is the brief explanation of a PNP transistor and NPN transistor. So a transistor has 3 electrodes: base, emitter, and collector. Emitter is heavily doped, base is lightly doped, and collector is moderately doped. Okay, moderately doped. and width of the emitter region is slightly less than that of collector region, and width of the base region is very thin. Width of the base region is very thin, and width of the collector region is moderate. Okay, students.